Astrophysics, is it math or exploration? A fascinating conversation with Matt O'Dowd, host of PBS's series Spacetime, racing towards you on Science Goes to the Movies. Welcome to Science Goes to the Movies, a look at the stories of science and how they change our culture. I'm Faith Salie, and today we're going to talk about the astrophysicist as explorer. And I'm happy to be joined again by Matt O'Dowd. Hi, Matt.
Hey, Faith.
CUNY astrophysicist and host of the very popular PBS series Spacetime. I think this is your third time back.
I know, this kind of feels like my second living room now.
Yeah.
I'm just going to be hanging out here.
Keep up the good work.
From now on.
All right, let's start with Spacetime. If you're not one of the show's million followers, Spacetime is a PBS digital studio show devoted to astrophysics, starring our guest, CUNY's own Lehman College professor Matt O'Dowd.
Are we alone? Recent amazing discoveries have given us more hope than ever that our universe is full of life. So why don't we see it?
Okay, Matt, the name Spacetime, it's a nifty science pun, correct?
Well, it is. I didn't come up with it. I wish I could say I did. It is a show about space most of the time. And so my favorite science pun,
Yes.
Spacetime pun, I guess, is that it took a long time for us to really understand the nature of gravity, and Einstein eventually came up with a theory about space. And it was about time, too.
Did you make
Really
that? Did you
terrible.
make that
I
up?
can't deliver physics jokes. No, it's an old one.
Wait, you speak of this as if there's a whole genre of astrophysics jokes. Is this true?
Oh, they're terrible.
Oh, okay. We have to devote another episode to hearing you try to deliver them. All right. Well, joking aside, what is Spacetime actually?
Oh, well, okay. So it is about space and about time, but so Einstein had this incredible realization that space and time aren't really separable. So, we have this sense that if it's 5 o'clock here, it's 5 o'clock everywhere in the universe.
Which means you have to drink.
Exactly.
Yeah.
It's always 5 o'clock somewhere.
Yeah.
There was this universal clock, and also that everyone who had a ruler would measure the same lengths if they tried to do so. But Einstein realized that none of that is true. In fact, clocks tick at different rates depending on where you are, how fast you're moving, whether there's a gravitational field around, and lengths change as well. The size of space and the rate of clocks depends on each individual observer. And space and time.
So it's all relative.
It's all relative.
Hence the theory of relativity.
Exactly.
Is that why it's called that? Okay.
Exactly. The theory of relativity. And the two, space and time, tend to meld into each other.
That's the part that lay people like me, I hear you say those words and I get it and I could repeat it to somebody, but I can't really get it.
But I think that's true also of professional physicists. I think professional physicists, they can do the math and they may start to have an inkling more sense, but I wouldn't say that many, if any, really understand what it means.
Thank you for saying that. You just changed the way I feel about not being a scientist.
Yeah, we all just get a little bit deeper. But what is space actually? What is time actually? I don't think anyone really knows.
Human beings have been excited about the sky for as long as we've had eyes. And since the silent film era, we've been making movies about the heavens. The first film set in outer space was the French film Le Voyage dans la Lune, released in 1902. And in the past 10 years, every year, we Earthlings have released at least 3 and sometimes as many as 13 movies that take place in outer space. That is a lot of movies, Matt. So what is so exciting about the sky?
I guess it's, maybe with the exception of the depths of the ocean, the sky or the universe is the last frontier. It's, the one thing that we haven't explored thoroughly. And I think if you don't know what's out there, then anything can be out there.
Yeah.
And that's pretty exciting. It's a place to maybe project our dreams, certainly for filmmakers who want to be able to explore all sorts of crazy ideas.
I mean, you're an astrophysicist, so I feel like I can ask you this question. How amazing is the sky?
I still get blown away when I look up at the night sky, and I can, see the band of the Milky Way across the sky and know it for what it is, that it's this vast spiral galaxy of 200 billion stars.
Now, in all those movies that take place in space, there are lots of fictional physicists, from Victor Bergman of Space 1999 to Amy Wong on Futurama. But our researchers could only find 4 fictional astrophysicists. And of course, please feel free to write in and tell us where we're wrong, because that is what the internet is for. But we found that the Stargate franchise has 2 astrophysicists, Samantha Carter and Rodney McKay. Star Trek had only 1 astrophysicist, Mr. Spock's father, Sarek. And of course, maybe the most famous fictional astrophysicist is Raj Koothrappali of the Big Bang Theory. So, Matt, the fictional Raj Koothrappali, studies trans-Neptunian objects. Is that a real thing?
It's definitely a real thing.
Okay.
So trans-Neptunian means a body that exists beyond Neptune's orbit, besides comets, which tend to come into the inside of the solar system. But there's this vast ring-like cloud beyond Neptune's orbit of icy, dark worlds and asteroids and dwarf planets and all sorts of stuff.
Wait, so this is assuming Neptune is the farthest out planet in our solar system, right?
So that would make Pluto a trans-Neptunian object.
Yes.
As opposed to, or technically a dwarf planet.
Okay. And where do you stand on this?
I mean, for the sake of future kids, I know it was mostly kids who didn't like the downgrading of Pluto, or ex-kids like myself.
Yeah, it hurts me.
Exactly. We learned 9 planets.
Yeah.
But future kids are going to have to learn thousands of planet names if we keep Pluto.
Oh, interesting.
Yeah. I mean, Pluto is not, there are other things like Pluto at close to Pluto's orbit, and there are other worlds of similar size there and further out.
And the fictional Raj Koothrappali discovered a planetary object beyond the Kuiper Belt, right?
Right.
Kuiper. Okay, so is the Kuiper Belt just another Raj bad fashion choice, or is that also a real thing?
That's a good idea, actually. Kuiper Belt, a wearable Kuiper Belt.
You can market that.
All right. So no, the Kuiper Belt is very real. It's this vast ring of, really it's debris left over from the formation of our solar system, the stuff that never made it to being a real planet.
Raj nicknames his discovery Planet Bollywood. Do you get naming rights on whatever you discover? Are there conventions to which you have to adhere?
It depends on your field. Unfortunately, in my field, I do quasars and distant galaxies.
What's a quasar?
Oh, okay. So the largest black holes in the universe, so supermassive black holes, these are the things that form in the centers of galaxies. Okay, you get this trickle down of material and other black holes raining down, and this central giant black hole grows. And during those growth phases, if the black hole is devouring gas from its surrounding galaxy, that gas kind of screams into the black hole's gravitational well, heats up, and shines with intense heat. And you can see these things to the ends of the universe. You can see them shining out from the earliest times.
We can't see black holes, but we can see this.
Exactly.
This
you can
heat
see
around it?
You can see their influence. You can see their energetic effect on their environment.
And sorry, that's called a what? A
quasar.
quasar.
Yeah.
Okay.
And they're cool, but they tend to end up with numbers for names.
Why?
Well, there are countless quasars. We know of hundreds of thousands of quasars, and so, we're just not that creative to come up with so many names.
In the show, Raj discovers this planetary object completely accidentally. And is that how discoveries are made? I mean, is it tons of people looking up at the sky and waiting for something anomalous to show up?
It used to be that, well, all astronomers were amateur astronomers because there was no such career. For example, Uranus was discovered by William Herschel, who was a musician. amateur astronomer, and he noticed this moving spot on the sky.
I'm sorry. Who decided to name it Uranus? And I still say Uranus. I'm sorry about that. Is that okay?
I've trained myself to say Uranus because when I teach,
I mean, you can't get the class back after you start out with
15
Uranus.
minutes of giggling.
All right.
I think we have the Greeks to blame for that particular deity.
Might as well. All
yeah.
right. When Raj gets his allotted time at the to look through the huge telescope that's shared by so many institutions, is he actually looking through a lens, or is that how it works, or is it his turn to interpret and control the data that's coming back to Earth?
The sad fact is, they're trusting astrophysicists less and less with using telescopes because the telescopes are now too complicated for us. So when I was a grad student, I went to some observatories in Chile, Hawaii. It's like some of the most amazing experiences of my life, going to these, still not looking through a lens, in the control room, look down. I mean, it's all electronic. These days, more and more, it's specialized engineers and technicians who run the telescope. And quite often we may be up at night in our offices while those observations are happening, but sometimes that's not even the case. If we can kind of characterize the observation well enough, then the technician will do it and the data will come back.
Wait, I don't understand. Characterize the observation well enough? So are you sort of assigning them? Like, what does that mean?
I mean, send detailed instructions for
what are those instructions like? In my mind, they're like, turn the lens a little bit this way.
That's the most important thing. Exactly, precisely where on the sky to look, how long to point for, things like what filters to use, so what wavelengths of light you want to observe this particular object in, because that makes a huge difference in what you see.
So are there scientists all over the world, like you, who I assume do some math and some research and send these instructions or requests to some place where this telescope is? So you do this remotely?
Yeah, often. I mean, it's a long process. You spend a long time writing a telescope proposal to be assessed by the time allocation committee, who convenes and maybe chooses 10% of the proposals.
So there are a whole bunch of scientists all over saying, please let
process.
me.
Yeah, and once you're selected, then you give very, very detailed instructions about the observations you need that will allow you to do the science you want. And then sometime in the next 6 months to a year, those will happen. So this is a particular observing mode. Sometimes you actually do apply to go to the telescope and do it yourself, but it's all this competitive process.
So something does not seem fair to me. Raj Koothrappali sits in a dark room somewhere in Pasadena, while other fictional astrophysicists like Sarek or Samantha Carter have these exciting lives where they get to roam the universe in much better costumes. So in real life, is that what most of astrophysics really is?
Definitely more time spent staring at the computer screen than at the telescope, unfortunately. Yeah, I mean, it's not a bad thing. Our minds are out there exploring the universe, I guess, maybe is a nice way to say it. But it may not look exciting, staring at the computer screen, but
it is to you.
Well, it is our way of exploring.
Is most of astrophysics math, or is it applying math to new data?
It varies. I would say that astrophysics that's only math, it's not really astrophysics until it's applied to data. So, but also only looking at data doesn't allow you to say much about what that data is. So I think they're married. There are really there are no astrophysicists who don't do a bunch of math, and there are definitely some theoretical astrophysicists who are very happy not thinking too hard about the data, being constrained by reality, but in the end, the two have to come together.
What is the difference between a physicist and an astrophysicist?
I mean, astrophysics is doing physics with stuff that's not the Earth. So thinking about the physics of galaxies and stars and space-time and the universe as a whole. It's a hugely broad field, and so often one astrophysicist will know nothing about the work of another astrophysicist. In the same way that physics is hugely broad, also whether you're talking about quantum mechanics or electrodynamics or so many aspects of the universe.
In the movies and TV shows we see, it seems like it's biologists and chemists who get to go to space, and not the astrophysics.
If only they'd
physicists.
told me that when I started studying. I thought, astrophysics, okay, so at some point I get to go on the space shuttle, right?
Yes.
Yeah, it's sadly true. We look out there and maybe point to the things that other people get to visit.
Why? Why don't you get to go?
Well, there's not much we can do out there. The telescopes are down here. They don't let us go up to the Hubble Space Telescope to peer through that lens. That's all done from the ground. But experiments in geology or biology, or searching for, extra terrestrial biology, that needs to be done in space. So the first people who land on Mars will be geologists and engineers and biologists, and we'll be waving from back at home.
Right. So Spock and his dad Sarek get to explore the universe physically, and real astrophysicists largely do it with math and data here.
Yeah. Well, again, it requires the two. I mean, so you could explore the universe and travel to a black hole or to another planet, but in the end, you're hovering above in your spaceship collecting light and other information. We do the same thing. Our exploration of the universe is very physical. We just collect that light from much further away, and that's often where the challenge is. The math, the computer modeling is trying to make sense of light that has been traveling across vast cosmic distances to fall into our telescopes. But we really are catching particles that were at those crazy astrophysical objects, and so it's a physical exploration and a theoretical exploration, because we need to then build our computer models to our computer models of quasars and galaxies. But that's also like exploring. It's building mini universes in your computer that you can play with. And
so it does feel like exploring to you, or it is exploring to you.
I mean, I think this is one of the most fun and most challenging things about really any science. I mean, the first thing a graduate student figures out when beginning is that there are no answers in the back of the textbook. There are questions,
Yeah.
and there are paths to answering those questions, but you don't know what the answer is, and you don't even know if the path you're taking is going to get you there. So that's another type of frontier, I guess.
Yeah. It seems lately, even if you're just reading the news, that there's an explosion of new data for astrophysicists to explore. Is that because there's more tech and therefore new data?
That's exactly right. Yeah.
Okay.
So, the example that we are most giddy about right now is, of course, gravitational waves. The LIGO observatories, which are incredible pieces of technology, are now detecting ripples in the fabric of space-time from merging black holes a couple of billion light years away, and other examples like improved detector technology, so camera technology in our telescope is allowing us to survey vast regions, indeed the whole sky, on short timescales, to detect all of the supernovae and all of the gravitational lenses. And I think we all have a sense in astronomy that doors are being flung open right now, and we have no idea what's going to be behind them.
Do you ever wonder, like, if Einstein were alive now with this technology, I mean, Do you ever think about that?
Yeah, I just got shivers when you mentioned that. Yeah, I mean, it kind of feels like we haven't had a true Einstein in a while. And so it's hard to imagine. But, it may also be true that as science becomes more and more narrow and specialized and detailed as we get deeper and deeper, that maybe Einstein would be in a similar position to the rest of us right now, almost overwhelmed by the complexity of these mysteries and also the potential. Yeah, I would like to know the answer to that question.
I recognize that they're both fictional, of course, but there's such a huge difference between Mr. Spock's dad, the astrophysicist Sarek, and the frumpy earthbound astrophysicist Raj Koothrappali, and yet they're both explorers in your mind, right? Are they?
Yeah, I mean, in the sense that I think science and astrophysics is exploration. They're very different, but I have to say that that Sarek is, in a way, more like many of the scientists that I know versus Raj Koothrappali.
In what way?
Well, he is. He's vibrant. He's worldly, galactic. What's the right expression? He's maybe a Renaissance Vulcan. He's like the ambassador to the Federation of Planets. He's broad and interesting, and that these are characteristics, and he's super cool, and these are characteristics that I tend to appreciate in a lot of scientists that I meet.
Whereas Raj is,
you do meet scientists who are more like Raj, but I feel like he's a missed opportunity, and maybe the whole Big Bang series is a bit of a missed opportunity. It tends to represent these scientists as
misfits.
Misfits, yes. Low functioning. Raj can't talk to women unless he's drunk, but there are other characters are in it. Deeply socially awkward, belligerent, sexually predatory.
Yeah, misogynistic. Yeah.
Right, and I feel like this. I mean, it's a known stereotype, but it's kind of a cheap stereotype, and it's not particularly accurate of most, high functioning STEM professionals. And so I feel like, if you're
so while there's kind of been this cultural narrative that a show like Big Bang Theory popularizes science, it sounds like it's not exactly. It may not be doing science any favors.
It may bring science into some more public consciousness, but I don't think it inspires future scientists.
So what comes to mind is like how cool all the CSI forensic scientists are, right? And they're gorgeous, right? And there's that cool lighting, and they're just so cool. And all these kids want to be forensic scientists.
Yeah, there was such a huge uptick in the number of people doing forensic.
Right, and so when a kid sees Big Bang Theory, especially a girl, let's just say a girl sees it, I think there's one or two female scientists on the show, and they've been more ancillary, right?
Right.
And they're not seeing.
And even the main female scientist is, not the main one. I don't remember who Sheldon's girlfriend is, but
Amy.
Yeah. I don't think she is what most young girls want to aspire to. So, when a kid is curious about science and really thinking about some of these kind of nerdy things, and is thinking about pursuing a career, seeing your dominant image of what a scientist is like is going to influence whether you decide to pursue that. And I
can't be what you can't see, is what people say.
You can't be what you can't see, exactly. And so, sure, this show shows that you can be a scientist, but it also shows you that if you are a scientist, then you're definitely not going to be socially accepted.
Yeah.
You're not going to find cute dates.
Do you think a lot of scientists feel the way you do about the Big Bang Theory?
Most scientists I know don't love the show. I'm afraid to say. I think we all feel a little stereotyped sometimes.
Yeah. You have such a strong and loyal audience for Spacetime. Do you think that maybe it's that adventure for that thirst for adventure that keeps them coming back? What do you think?
Who knows? We were incredibly surprised. We thought that we would do a show that took science a little bit further. That people have been enjoying kind of science made fun for a long time, and we thought that there was probably an audience that was ready to graduate to. We just try to tell it how it really is in science, rather than rely too much on analogy and it turned out there was a massive appetite for that. People are smart. People are super smart, and they know when you're talking down to them. And so I think that's part of it. But I also think the universe. It's so mysterious. It is like the fundamental workings of the universe are the fundamental workings of us. We're part of it, and people sense that, and so it kind of feels like you're learning magic when you learn how the universe works.
That's a wonderful way of putting it. That kind of makes you a magician.
Yeah, right?
Yeah, it does.
Right?
Thank you for making it so compelling. And I wish we could stretch space-time to keep you here longer, but we'll just have to ask you back, because
Please.
you are our most often repeated guest.
Oh, wow.
Thank you.
Number 4.
Thank you so much for joining us today.
Thank you so much.
Be sure to check out our Science Goes to the Movies Facebook page for web-only clips, and to keep up with everything related to Science Goes to the Movies all in one place. And if you want to watch past episodes, check us out at www.cuny.tv under the Science tab, or try out our new YouTube channel where you'll find lots of science and movies.